This is the story of an email that physically could not travel more than 500 miles. Under 500 miles, every message arrived perfectly. Past 500 miles, every message died. The same exact distance, every single time. It's true, and it accidentally measured the speed of light. Better still, it hides 3 lessons every engineer needs. Fail loudly, define your weird values, and check what your code is really running. Let's dig in. Back in the 1990s, at a large American university, the campus email administrator received a strange phone call. Our emails cannot travel more than 500 miles. The IT administrator laughed. Email doesn't work like throwing a ball. Sending an email to the next town, or across the ocean, takes the exact same effort. But the caller was a statistician. And he said the most dangerous words in engineering. We have data. For days, his department had tracked every email on a map. The failed emails formed a perfect circle around the university, radius, just over 500 miles. Inside the circle, emails worked. Outside, they failed. The IT administrator tested it himself, and realized the bubble was real. When he investigated, he found the problem. Someone had accidentally installed a very old version of the email software, like downgrading your smartphone to a model from 10 years ago. When software downgrades like this, it can't read newer settings files. Instead of showing an error message, the old software simply ignored the words it didn't understand, and used its own built-in default settings. One of those default settings was the timeout. How long the server waits for the other computer to reply before giving up. The old software's default wait time? 0. If the wait time was 0, why did any emails get delivered? Think of a delivery driver at your apartment building. His rule: wait 1 minute after ringing the bell. Ground floor resident? Grabs the package in 2 seconds. 15th floor? By the time the lift comes down, the driver is gone. In fact, there is one exact floor, say the 9th, above which nobody can ever receive a package. Not slow, not lazy, just. The lift takes longer than the driver's patience. The email server was that driver, except its rule said wait 0. And even with 0 patience, the old computer needed about 3 milliseconds just to turn around and leave. And in 3 milliseconds, light through a glass cable can travel out and back, about 500 miles. The statistics professors hadn't just found a software bug. They had accidentally measured the speed of light in fiber lines, using failed emails. To fix it, the IT administrator simply reinstalled the correct software version. The server understood its settings again, waited properly, and the 500-mile limit vanished. For software engineers, the real problem here wasn't the timeout value. Remember the 3 lessons I promised? Here they are. 1. Fail loudly. In Spring Boot, bind your settings with configuration properties and add validation, a minimum of 1 on that timeout. Now if anyone sets it to 0, the application refuses to boot in 2 seconds with a clear message. A crash at startup costs 5 minutes. A silent guess cost that university days. 2. Define every weird value. Java sockets made the decision for you. A timeout of 0 officially means wait forever, documented, deliberate. And connection pools like Courier reject or repair absurd timeouts at startup itself. 0, negative, empty. In modern code, every strange value has a decided meaning. In 1996, nobody had decided. 3. Check what the software is actually using. Enable Spring's actuator env endpoint, and one call shows you every setting the live application holds, and which file it came from. The gap between what the file says and what the process believes, the gap that hid this bug for days, becomes visible in one request. And one final warning: when you upgrade Spring, take care of the configuration changes. Property names get renamed between versions. The old names are silently ignored. The compiler says nothing. The build says nothing. The bug appears only at runtime, only when that feature is actually used. Add the properties migrator dependency during upgrades. It detects old names at startup, warns you loudly, and even remaps them temporarily while you fix your files. One setting drew a 500-mile circle around an entire university. Next time. One leftover flag that burned $440 million in just 45 minutes. See you in 2 weeks. Please subscribe for the next story and the next engineering lesson.